When we dig a soil pit, the first thing we look at are the soil horizons. These are the different layers within the soil, and they have different chemical and physical properties. And we can look at the thickness of the soil layers, the soil colour, the texture, the structure, and how they feel when we touch them. From these initial observations, we can start to work out how water may infiltrate after rain, how the soil stores water, and I guess how much water is going to be stored within that soil for plant growth throughout the year. However, some of the soil properties we can't see, so we need to take simple tests or laboratory analysis to find out more about those chemical properties and how they may be restricting plant growth. Some of those chemical properties within the soil are things like how many nutrients are available, how the soil stores those nutrients and holds on to those nutrients. Other chemical properties include how acid the soil is and how the soil reacts, how the soil particles react when they're wet. So let's have a look at the soil pit. Initially with the soil horizons, we're looking for changes in colour and texture. Most farmers would call this the topsoil, and then moving down into the subsoil, which is sort of heavier in clay and a different sort of colour. Soil scientists would refer to this as the A horizon, and then further down maybe the B horizon. Now our typical soil tests only go down to about 10 centimetres in depth, so we don't often know what's happening below this and whether there are chemical and physical barriers that may be preventing root growth. Colour can tell us quite a bit about the soil and what's happening. So the topsoil here, it's sort of darker in colour because of that organic matter, and because the organic matter's there, a lot of the nutrients will be there as well, and a lot of the soil biology would be working in that area as well. This next layer down, it's a little bit, sometimes it can be a bit paler in colour, but it's still a sort of, I guess, very similar sort of grey colour. This next layer, we start to see sort of more orange and reds occurring. This sort of indicates that a lot of water can sit in this area when you start to see that mottling. So water sitting in this area and it's not sort of draining down below. And we sort of move again into a very orange and yellow looking clay. And yellow and grey sort of clays often indicate that the soils can be quite sort of saturated with water. The other things that we're seeing, I guess, is some sort of darker colours from organic matter that has decomposed within the soil. And in some places within the soil we can sort of see whitish sort of little rocks which are carbonate, which is basically sort of lime within the soil. And we're wanting to confirm if it's carbonate. So what we've done is we've added some acid to it. In this case it's just vinegar, and because it's fizzing it indicates that it's carbonate. If we chip out some of the soil, we can start to see how some of the soil particles bind together. This is the soil structure. The structure can be examined straight on the pit wall, or we can also take out crumbs and add them into water to see how they react and whether they hold together. The soil structure is different for each of these different layers. At the surface, the structure is quite nice and friable and crumbly. This next layer down, it's sort of similar. It's probably a little bit more clayey, but still good for roots to grow through, and we're looking for soil pores so that water can drain through quite easily. It's getting a little bit harder there, the next layer down. And then when we move down into the subsoil, it's quite dense and firm, but we can see that roots are getting down to this layer, and we can see some old root channels as well. So when we do a dispersion test, what we'll be doing is that when we take some of these crumbs of soil and add them to water, we see if those particles will remain sort of nice and aggregated and hold together. If they've got too much sodium in them, they can dissolve, or not dissolve, but separate, the clay particles separate out together and don't hold together very well. There was no sort of sodium issues in this topsoil part, but in the subsoil we've got increasing acidicity occurring. One of the main reasons for the differences in soil structure is the amount of sand, silt and clay, and in some cases gravel within the different soil layers. We can estimate the amount of sand and silt and clay by feeling the soil and seeing how it holds together when it's nice and moist. So this is the topsoil, and its soil structure, its soil texture is a clay loam. The next layer down, it sort of can be pressed into a ball, and it's getting increasing clay content within it. I can feel the clay. It's sort of quite easy to press together. As we get further down the layer, that clay becomes quite heavy and quite plasticine to feel. With an understanding of the different soil horizons, the soil structure and the soil texture and the soil colours, we can get an idea of how the water moves through the soil and the infiltration rates. At the top, the water's going to move through quite quickly, and it'll go through at about sort of maybe 5 mils per hour, but then it'll start to slow down as it moves into these clay layers, and it might only sort of move through at 1 mil per hour. You'll get the soil water starting to bank up in this area along here where all the mottles are, and this can be considered a perched water table. We can see the roots growing all the way down to about 65 centimetres, and we can see some old root channels down to about 70 centimetres. So we know that the roots are extracting moisture from those levels. So what we can do is that we can start to calculate how much each of these layers will hold on to moisture and store moisture, and each layer will store moisture differently. Some of the other things that I can see in this soil pit that are interesting are the little sort of gravelly bits of soil. In this particular layer, we're starting to see some buckshot. They're little nodules. They're formed through iron and manganese being exposed to water and coming out of the solution, and then when the soil's dried over many hundreds of years, they're formed little nodules. Now, little bits of buckshot like this is okay, but sometimes we find big layers of buckshot which can actually provide a physical barrier for root growth. The pH at this soil was 6.6 in the 0 to 9 centimetre area, which is good, and it reflects that the paddock was limed last year. Drops down to 4.5 in the next soil depth, and this is a test in calcium chloride. That's very acidic and would be preventing root growth, potentially, particularly of acid-sensitive species. That pH increases with depth as we go down the profile, becoming quite alkaline.